Hello, this is I'm practicing for the 129 interview assessment for launch school, and I'll just be going through all the concepts that are there in the syllabus and try and answer them. I'll be sharing my screen, probably working on Sublime Text, uh, and I'll just get rid of the other apps open and then quickly hide this. Yeah, okay. Yeah, so the syllabus for this exam is to talk about the following. So I'm going to just list them down. So I think I am not in a bad place in terms of explaining the concepts. I want to work on the narrative right now. The thinking behind this is that I want to start with showing how something like this might work in a procedural or procedural way, and then show how OOP changes that situation, and probably even illustrate the benefits of OOP along the way. My written assessment told me that it was actually a very good experience because it made me think in a theoretical way instead of a practical way. And I spent quite a lot of time thinking about the idea of keeping code dry, and that pushed me to be bolder with my choices because this was a purely theoretical exercise. Um, so the things that I got wrong during the assessment were things that I actually didn't know. The fact that kernel is a module, for example, um, and of course, now that I look at here, it's clear. So what this did for me was just to think of the fact that not everything is a class by default, that there are quite a few modules in Ruby, and you should pay attention to what is a module and what is a kernel. Uh, yeah, so that was good. Um, okay, cool. So one by one, I'll go through all these concepts. I do have some examples and some notes with me. Um, for now, actually, I think it's good to uh, for now, it's good to actually not refer to my notes because I can look at this video again, go back to my notes, and have a better understanding. Okay. Uh, yeah, have a better understanding of where things are, where my knowledge is right now, and then I can improve this for the assessment. The idea is, of course, even the assessment is not the ultimate destination. The ultimate destination is the understanding. So if I make mistakes during the assessment, I'm okay with that. Yeah, so just a second, let's save this file. Okay, so let's head to CodePad, because that is the environment in which the test happens. Yeah. Head to the dashboard, and I think I do have a pad created already, so I can just head to that. You have 4 days to work with a pad like that. Yeah, so the first topic to talk about is classes and objects. Throughout the program, we've been talking about the fact that classes are blueprints for objects. And the idea is that classes provide the core information, and classes provide the states and behaviors. Classes help define the states and behaviors associated with an object. While a class is an object of the class class in Ruby, for our purposes at this point, we're I think talking about a level of abstraction higher than that, and we're talking essentially. So if we look at we have this whole object kernel and basic object. These classes that are going almost underneath the main that we're working with right now. So I think we want to talk about classes that come above this level. So above main, on top of main. What do we build inside of main? Classes typically contain, as I said, states and behaviors. If you're modeling a problem, like Sparky is a dog that is 12 years old and male and likes to bark and eats fish and swims, let's say. Then we see that we can model this behavior into one object, which would be a class. As in, we can create similar dogs of this nature, and a class is an abstraction of this. So we can initialize this dog with a name and age, and we can say give it some sort of. So these would be the states of this object. Age, gender, So, and then we can also indicate that there's a certain behavior here, which is the ability to swim and the ability to bark. Now, we have this class called dog, and we can instantiate it using the constructor method initialize, and create a new object with certain characters, like let's say Sparky, age 12, gender. I'm just going to go for a symbol here. Or I think because we have like a two or like not that many options for gender, so it's okay to go with a symbol. Now that we've instantiated this object, we can call the behaviors on it, like dog.swim or dog.bark. Yeah, so we have states of this object, which is indicated if we just inspect the object, and we are seeing these three states, which will vary from object to object, but the behaviors will not. So every object will have the ability to use swim or bark, while the behaviors are likely to use the states for some purpose or the other, but every object of the same class, every object instantiated from the same class has access to these variables. Yeah. Okay, cool. So that's classes and objects. What else can I talk about? Yeah, so everything is an object, of course. So like if we look at a string in our REPL, we'll see that even the string Ruby, if we have a string called Ruby, we call .class on it, we can see that it's object of the class string. And we can use our knowledge of this new initialization by creating an array, let's say. And we now know that this constructor and there are some parameters defined, so we can say 2, 2, and we'll get a 2 array of size 2 with both of the initial values being 2. So this opens up our understanding of the world of Ruby as opposed to before. Okay, cool. So next I'll get to attr getter and setter. At this point in this program, we do not have access to the name itself. We can call bark or swim, but we try to do that. Then we get an undefined method name. We can expose this interface by creating a method like this and exposing the name. And we can also do something like we can change the name as well. Like this. So yeah, and now if we do pdoc.name, we see different names. Ruby does give us some syntactical sugar where we can use an equal to at the end of the name of the setter method, and we can actually use the reassignment symbol. And this makes it closer to our expectations with the way Ruby is working till now. And we can even, if we're not doing any further modification, if we're not doing like we're not adding something or we're not doing some processing of this information, we can in fact capture all of this into one line by using this term called attr accessor. You could have used attr reader if you're only reading the name of the variable, writer if you're only writing, and attr accessor if you're doing both writing and getting and setting in essence. And so in one line you can achieve this for all 3 variables. So this code would still work. Yeah. So in this case, like if you're talking about attr getter, then the attr getter is attr reader essentially. An attr setter, attr writer. Calling getter and setter, I think I've covered this already. In getting to get attr setter, attr accessor, I think I ended up getting there. Maybe we'll talk about the syntactical sugar here, but also I've covered. Okay, instance and class methods. So all of these methods that we're using here, such as dog.swim, dog.bark, dog.name, these are being called on an instance of this class. If we wanted to call a method directly on capital DOG, we would call it with the self keyword, or you could even do, let's say this. We do this. We then inspect this. So this happens where now we don't actually need an instance of the class. We can call it directly on the class. So this, in this case, this is the class method. We typically don't use the class name itself because I think this we use the word self, which is the same thing. And this helps. See, you can see it here in the first line that this shoot up as capital dog, and this helps, I think, with copying methods between different classes. Maybe it even helps with subclass with inheritance. So let's say I'm making a new class called bulldog, and then making a subclass of like this. Now I think I can do the same thing, and it will work. I mean my dog. Okay. Yeah, but if I don't use self here, if I want my dog, then that would have also worked. Okay. Yeah. So what's happening in this case is that first the class looks for an instance, a class method inside of bulldog class, but if that it doesn't find it, then it goes higher up the chain and finds this one called hello. Yeah, okay. In this behavior, I think this needs to be checked up. Just a second, guys. I'm making notes. Okay. So once we add instance variables into the mix, it actually starts becoming useful. Where if we refer to our, so by the way, initialize is also a class method. It's not immediately obvious, but you call it by calling dot new, and if you try and call bulldog dot initialize, you won't have access to it. It's a unique method in some ways. Now, if we try and access the number of dogs by creating a class method, birds, dogs, and yeah. And if I do another dog, let's see, we can. Yeah. Okay. Another interesting one is that subclasses, when they instantiate, follow the same initialize as superclass, and CVAR is increased, increment. Okay, Cool. Yeah, so class methods typically act when there is no object involved, or like at the time of initiation. So their scope is different uh, from an instance method, because the state that they're capturing is relevant to the class and not the instance. State and behaviors are both relevant to the classes and not the instance. Don't have much else to say about that. Instance and class methods, yeah, I just talked about that. Instance versus getters and setters. I did talk about the fact that if we use what are the sources, I'm going to check this out. Support curriculum. Maybe I contracted too much. It's asking something else. Yeah. We call it referencing and setting instance variables versus using getters and setters. Yeah, so the advantage of using the add getter setter is, of course, concision of code, where one line we're achieving what otherwise would take 3 plus 9, 9 plus around 10 to 12 lines of code. And if we're not doing any further processing, then it doesn't matter. However, if we have a case like we want to nudge me here, that let the dogs have a social security number. And we make this a private method. And so let's say we give them 1 to 100 to 999 s plus. Let's just make it this. Let's make it a 4-digit number, and we only want to reveal the last 2 digits of this number. Okay, cool. Now, what we can do is, if someone wants to see the SSN, say at SSN, say it's plus at SSN. Since it's a string, we can go like -2 to -1. And now, when someone wants to find out what the SSN of dog is, we do p dog.ssn. In that, just yeah. Okay, XX65, right? So we are hiding the details. We're only giving the last 2 digits. We can make this more complicated and basically something like this and like that. Runtime increases, but we can be more logical about this. You can say at SSN 0 to 3 dot length dot times dot. Yeah, we can do this if you want. Or we can show the last 4. Yeah, you can do this as well. But yeah. So our create SSM method is random then. You cannot set it. You can read it, and when you read it, you get a certain amount of information. That's useful, as opposed to an ATO setter, which is ATO reader and ATO writer, which are direct in doing this. Okay, cool. We can move on to the next topic, which is the idea of itself and the 3 crucial topics of inheritance. Part 1 by 1, inheritance. Okay, I'll just sorry. Encapsulation. Yeah, so inheritance allows us to inherit behavior from certain number of subclasses or superclasses or models. Right, nothing I'm talking about. Absolutely. This allows us to have a boilerplate that we can build on top of, and allows sharing of code in some ways. It reduces redundancy and allows us to keep our code dry, to not repeat itself. Yeah. So what we typically have is with inheritance is that we have a class, and that has some core behavior, and then you have some behavior which you build on top. So the base behavior this class would have, plus it would have some divergent behavior. And another one will have the same situation where there will be some base plus some divergent behavior, which is again different from this one. Now, call this core also. Now, in a non-inheritance situation, we would write this core behavior and states again and again. So we would repeat it 3 times. But instead, if we do a simple inheritance, then we just have to define this behavior. So we have a situation where in inheritance we model what is called an is a relationship. So in this case, cat is an animal, dog is an animal. We could even have bulldog. I like bulldogs. Bulldog as a subclass of dog because bulldog is a dog. And so the bulldog could have even more yeah, the dog in this case would bark, let's say. And a cat would meow. The thing is, each of these would be unique to these classes. So a bulldog could grit its teeth, would bark, while a cat would meow, but a cat would not grit its teeth or even bark. And then we have here, then we can then just initialize with the name and age. Because every animal, you'd expect every animal to have name and age. Yeah. And then this way, we have a superclass at the top. We have subclass. So you can see the hierarchy. This goes 3 deep, 1, 2, 3, and the cat goes 2 deep, 1 and 2. And so this boilerplate allows us to not means that we don't have to define a name and age for every animal, and all of them can jump. So we can call the jump method on any of the instances of these animals, and it'll all work. Yeah. I don't feel like running the example code right now because I think it'll work, and I think the logic is quite straightforward. So inheritance is done. Now let's talk about polymorphism, which is actually, I think, that is quite not so well explored. So my understanding is that polymorphism is the idea of many morphism, morph shape, many. So having many shapes. So the idea is that the same that Ruby allows us to respond to the same method or same message in different ways. And crucial to this is the idea of inheritance. We go back to our cat dog animal situation and initialize the name and age. Now, if we do a string conversion of this, we can say the name is and is and we can hard code even certain behavior into this. We can say also use super in the constructor method. I think the point is being conveyed here. And so if we instantiate this, we say cat dot new a6. We put this in. To end. And 24. Of course, this is def. And that is also def. I'm a bit nervous right now. Apologies. Scruffy is a cat and it's 6 years old and loves to meow. And if we do key and 12, and also we do animal, I could call down gates on this and even sorry. Uh, yeah. Okay. So this is my understanding of polymorphism, where animal responds to the 2S in a certain way, cat responds in a certain way, and dog responds in a certain way. Um, and we're going with the same states. So name and age is inherited, and the cat is doing its own thing on top. And then we have encapsulation. Encapsulation is the idea of information control. So we have certain access control methods in Ruby, and we can reset some methods, and some methods can be in the public interface. Things that need to be accessed, that things that we feel ought to be accessed outside of scope. While some methods remain private to the class, and some methods are accessible to instances of the class. Uh, let's go with this idea of identity. Let's say we can give an attribute read of this. And so we initialize these instance variables and we provide them the name passed on as parameters. And we also want to create an SSN. Again, I'm reusing a I used before, but I feel like it's a pretty solid example. So let this be. I don't want anyone to be able to write an SSN. I want an SSN to just be created. Now I'm giving an instance method which I'm making public. And I'm only providing a certain amount of information about the identity. Yeah. So this is let's just work with this first, and then I'll go on to explain what the advantage of protected method is. Take my example. E dot SSN. If you want to output this to the screen or inspect it. Wrong number of arguments. Because I've used initialize and not initialize. Please be there. Please be there. Okay, I'll start again. Yeah, this is a private method, and it's my public interface revealing however much of the physical number I actually want to reveal. Now, if I create an instance of this identity class, now inspect the output, I should get something that works. Yes. If you want to see the actual value when you find there's a binding apply here, and you can actually see yes. So this is 5.874, and if I do next to this, I get a 874. I get this thing. Okay, so this proves the value of a private method. Now let's talk about protected. I'm not even given auto reader here, right? And if I want to compare the age of myself with another person, I can do something like reveal my age to the other person, to the other, only the other instance of this object. And then I can go like at age greater than other person at age. Even just go age. I think I can do this. Or I can self.age just to be super clear, but let's just try with age first. I'm going to remove this binding, and I'll compare my age to my dad's age. And then I can say add older than me. Older. Yeah, so that should be fine, right? Can't we do this? She can be Yeah, because that has to be a public interface. However, my actual reader can be protected. So these two can go out. However, yeah, but this, sir. The key is that this method is the one that needs to be protected and accessible to the other instance. However, if I call me.age on this, it will be a protected method. Error. Yes. Okay, so that is encapsulation. Next up are modules. So we talked about is a relationship. This one is more of a has and ability to relationship. This calls for inheritance. And this calls for modules. Modules play two roles. If we have, let's say, an animal, we have cat is an animal, and lion is a cat. Let's say lion is a cat. All of these are hierarchical. Only one can inherit from. You can have only one superclass. So it's single inheritance. What if there was also this? What if you wanted a class to have two things to inherit from? An animal, and also let's say you want to talk about something like ability to swim. You can't do this. Instead, what you can do is you can mix in a module. So what you do is then you create a module here, you give it some stuff, and that stuff can go into this class. So we can include many things like this. Include some. And this relationship is called an ability to relationship, so it's defined this way. We typically have a tendency to just add able at the end. Able ability. This is the reason we append this to make it very clear. I think that it's a module and it can be mixed in. So in this case, it's facilitated for inheritances, the animal superclass and these three modules. Module will have some logic of its own. Let's say in case of swimming, we give it a method. If we say we have this, and then let's say we have a class animal quickly, and we have a cat, and this also ends quickly. Class. But for now, let's just give cat two inheritances. Let's say walk. I'm not giving any states right now. It's not totally crucial for this example. Now we do cat.new. We do cat.walk. We do cat.swim. So you're starting confidently from the superclass and you're swimming from the module. And also you call ancestors on this. You can see where the program will look for certain method names. Output it. So the class cat will look within itself, then we'll look inside the included module, then we'll go up and look into animal, and then it will look into these internal situations. So while you have multiple ancestries, this is something you plug in and has an ability to. So when we are modeling a situation, cat is an animal. Cat has an ability to swim. Not all animals have the ability to swim. Uh, so this is crucial for understanding where to use modules and where to use subclasses and inheritance. Um, the other thing with modules is that they provide namespacing. So, simple example is the sign method. Let's say it's not there in, it's not included by default, but in Ruby, like okay, let's say you want to you have two methods by the name sign, and you want to differentiate between the two of them. If you include them in different modules, then you are indicating that the sign that you're using is in the domain of mathematics. So if you run this here, you get a certain value. The sign value of 60, this is not in degrees, so I don't know what the unit is actually, to be honest with you. That's radians. Yeah, I don't remember my sign values actually. That's why this was not that easy. So you have a constant called pi also accessible, and you have a method also that's accessible. Okay. These are two use cases of modules. I go to Sublime. Okay. Self. Self is a reserved keyword. It returns the current object. So in this case, like in the REPL, we're saying that it's an object of an object called main. If you look for the class of this object, we get the object of class. It is an instance of class object, and this is useful uh, in our classes to specify scope of what we're working at. Um, if we run this code, we are processing self twice. In the first case, the scope is the object, or is the class definition, the class itself. In the second case, it is an instance of the class. So we can use this to define class or instance methods. In this case, here self is animal, so we can do this. We can't replace this here because every object has a different object ID, and every object is different. So self returns contextually relevant information, and this is useful. Also, this is useful for this case where we've specified whether it's a class method or an instance method. It's also useful in inheritance. Let's say this is the case. In the first case, it's being called on the superclass animal, and in the second case, it's being called on the subclass cat. And since we use self.class.2s here, it will give us the contextually relevant information. And once we throw in my name is this and I am at this, then we can in fact have one method here, but this has a dynamism to it in the sense that you can It's useful for the superclass and the subclass. Uh, Anything else about self? Self. I think for now we're good with self. Self, more about self. So let me just go through the launch school curriculum and see if I'm missing anything. Self helps out in the case of atom. Where if we do this, it won't work because we'll just create a new local variable inside the class. But if we just confirm that for you. If I do this, it will change. Why? Because a local variable is created. But if I use self and I make it explicit that I'm referring to the method created in AtSSL, then I can make this change. This is particularly important here because to avoid this confusion, but because of this, it's become a convention to refer to self like this, just making it explicit that we're referring to an instance method and not anything else. Yeah, okay, cool. Fine. Move on to the method lookup path, which I've talked about already. A bunch of classes that are inheriting, and you include a bunch of methods. We talk about the order that the modules go up in, and also right now is a good time to just check the ancestry, what each thing is. Like kernel is in fact not a class but a module. Object is a class, kernel is a module, and basic is a class. Thanks for that. Fake operators and equality. Yeah, it's the fact that this thing is actually not a operator but a method. Find in the comparable class, and we can override it so that we don't end up comparing object IDs and instead compare the things that are relevant to the class, like name, age. We decide what is relevant. Truthiness, yeah. True dot class has its own class. False, false has its own class. Nil has its own class. And only false and only things that evaluate false and nil only things that return false and nil evaluate to false or or are called falsy, and everything else is truthy. So if you run in the okay, good time to come up with an example. If this hello else right. Yeah. Yeah, so you might say that you're ambiguous about it, but since it's anything but nil, it is value it's false. So something like this also, an empty string would also be considered welcome. So you need to be explicit about this false. Yeah, truthiness, collaborator objects. We talked about two relationships till now, Isler and Hasser. Collaborator objects are has an ability to so has a and this is important when our classes are getting heavy and we can split responsibilities between two classes. Um, so let's say we are going to open a library. Uh, and we initialize with, let's say we have a thing called books. Let's say we initialize nothing. Maybe we come up with a hash for this. It's messy once the books start getting more and more information about them. Instead, what we could do is have a different class and then make this into an array. And we can give information like name and author to the book, and then you can start in functions this information. Um, and instead, you just simply add this book object And therefore, it's liberating for both the library and the book because the library can start thinking about bookkeeping. And yeah, you can do this instead. And so you're operating the array level here, and you start thinking about more important things like. So now can uh, you can think about the return date here instead, and say, and then you can compare. You can is equal to something, and you can do this. Now we can start thinking about f is book. Now we can start return book. If book dot return date is greater than book dot return date, then you can punish whatever you want and smile at the reader end. So by being independent, you give both of these the chance to grow, and you just need to know a little bit about the data structure here. And they're smaller. You don't have to deal with author and name at every stage. You can just deal with this book object, and that's handy because then you can keep your classes independent and reusable. Tomorrow, I might decide that this book is, structure is useful elsewhere, and I don't have to necessarily spend time changing and extracting information. Yeah, okay. So I think I've covered everything. I want to take 15-minute break before my session, Catherine. And I'll review this tomorrow, probably. To finalize my narrative a little bit. All right, cool. That was it.